6.2 using the event loop and coroutine scheduler. We're going to take a look at how to create a coroutine, how to manage the scheduling of them so that they act as if they were parallel processes, at least from a logical perspective. And we're going to see a minimal example of running multiple threads of code execution without running multiple processes. It's easy to create a coroutine. All we have to do is use the asyncio.coroutine decorator on a function and use yield from anytime we want to call other coroutines. As in this example here where we're calling asyncio.sleep, which is a coroutine, from with our example coroutine using yield from. Once we have a coroutine, though, we can't just call it to start the ball rolling. If we try to call it, it just immediately returns a generator object. That's not much use. Instead, we need to add the coroutine to asyncio.'s scheduler as a new task, and then we need the scheduler to run, arranging for coroutines to execute and handling input and output events. The asyncio package automatically creates a default scheduler, also called an event loop. While it's possible to create new event loop objects, or to replace the default one, for our purposes the default will work fine. We can get a reference to it by calling asyncio.'s getEventLoop function. To tell the scheduler that we want it to start a new task running a given coroutine, we call asyncio.'s async function. By default, this will create a task in the default scheduler, but we can override that by passing an explicit event loop to the loop keyword-only parameter of the async function. Notice that we didn't just pass the coroutine object to async. We actually invoked it right there inside async's arguments. The async function doesn't actually want a reference to the coroutine function. Async wants the generator that we saw the coroutine function return. The async function adds the new task to the scheduler whether it's called from the normal code or within a coroutine, which means that anytime we want to run a code in its own stream of execution, we can use async to get it going. Even now that we've added the coroutine to the scheduler as a new task, nothing happens. That's because the scheduler itself is not running. That's a problem easily solved. We just need to call either the runUntilComplete method or the runForever method of the event loop. RunUntilComplete accepts a specific future as its parameter and returns the value of that future when it finishes executing. RunForever, of course, doesn't finish executing until it's explicitly stopped, and so its return value is not of any great value. As the name implies, runForever causes the event loop to run forever, or at least until it's explicitly stopped by calling its stop method, while the runUntilComplete method causes the loop to keep going until a particular future object is ready to provide a value. The return value from async is a future object, so it's easy to have the scheduler run until a particular task is done. This example runs two coroutines simultaneously, as two separate tasks in the same scheduler. Coro1 coroutine contains an infinite loop, so it will never finish, but the Coro2 coroutine not only finishes, it eventually calls the event loop stop method to force runForever to terminate. This example behaves in exactly the same way, except it uses runUntilComplete to automatically stop the scheduler once Coro2 is finished, instead of explicitly calling stop. The code looks a little cleaner this way, so as a rule of thumb it's probably better to only use stop when some sort of an error makes it necessary to dump out of the event loop. In both of the examples we've just seen, there's a line of code to set the logging level to critical. That's because the event loop issues an error message to the screen if it is stopped while there are tasks, such as Coro1, still running. In this case, we know it's still running and we don't care, so we suppress the message. It's usually better to wait for all of our running tasks to exit cleanly instead of just killing them like this, which is why the error message is printed. But in this case, there's no problem, so we just keep the error message from showing up. Regardless of how we choose to run and stop an event loop, once we're completely finished with it, we should call its close method. That closes any open files, network sockets, and other I/O channels that the event loop is managing, and generally cleans up after it. A good way to handle that is using the contextlib.closing context manager, which guarantees that the close method will be called, even in error situations. The close method should be called when we're completely done with an event loop, but that doesn't necessarily mean it should be called right after runForever or runUntilComplete finishes. The event loop is still in a valid state after those calls are done, and it's perfectly okay to, for example, add some new tasks and start the loop running again. As you've probably noticed, asyncio event loop objects fulfill basically the same role as concurrent.features executor objects, from a programming interface point of view. That's not the only similarity. So, coroutines are created using the asyncio.coroutine decorator, and there's a default event loop already set up for us. The asyncio.async function lets us launch a new parallel task, and we can run the event loop either forever, or until we stop it explicitly, or until a specific process ends. In the next video, we're going to look at async.io's future class and how it's used.